Imagine you're building a birds game in Java. You create a class called bird, and you think every bird can fly, right? So you write, it looks perfect. Then you add a penguin class. Now watch this. And Java says flying. It means a penguin is flying? Congratulations. You have just created a bug by using inheritance. But here's the interesting question. Was inheritance the wrong choice? Or should we have used composition instead? Today, I shall explain inheritance versus composition in the simplest way. I will use Java examples. And by the end, you'll know exactly when to use each one. Let's start.
First, let's understand inheritance. Inheritance means one class can get properties and methods from another class. We simply understand inheritance by example. Firstly, we create animal class. Now, let's create a dog class. Here, extends means dog gets features and methods from animal. Think of it like this. Animal is parent, dog is its child. So the child can use things from its parent. This concept is called inheritance. And inheritance usually represents an is-a relationship. This means one thing is a type of another thing. For example, a dog is an animal. A cat is an animal. A car is a vehicle. When that relationship is natural and stable, inheritance can work really well. Let's go back to our birds. Suppose we write, and then create an eagle class. This is perfect. An eagle can fly. But when we create penguin, penguin automatically gets fly method. The output is, but we know that's wrong. Now, you might say, no problem, I shall just override fly method. Sure, we can do, but think for a minute what we have done. We gave penguin a method fly, but penguins cannot fly. So now we have a problem. We have to say, actually, you can't do this. That's not a very clean design.
And this can become a bigger problem as the application grows. Instead of thinking, this object is a something, we think, this object has a behavior. Let's separate the flying behavior from the bird. First, create an interface. Now we can create different implementations. For birds that can fly, and for birds that cannot fly. Now our bird class can have a flying behavior. Look at this line. The bird has a fly behavior. That's composition. Now let's create our birds. When we create penguin and can pass cannot fly interface. Now we create object from our classes. We can get output. This is perfect. The eagle flies, but the penguin does not fly. And we do not need any fake behavior.
Now, imagine this is a video game. Normally, our penguin can't fly, but the player gets a magical power-up, and suddenly, the penguin can fly. With composition, we can change the behavior. Now our penguin flying. We did not rewrite the penguin class. We did not change the entire class hierarchy. We simply changed the behavior. That's the power of composition. You can combine and change behaviors more easily.
When should you use inheritance?
Use inheritance when you have a genuine I-is relationship. For example, dog is an animal. Cat is an animal. Car is a vehicle. When should you use composition? When behavior can change in future, different objects need different behaviors, you want more flexibility, your system is likely to grow. So here is the golden rule. Favor composition over inheritance. But remember, when you have a choice, think about using composition first. This does not mean inheritance is bad. It simply means don't use inheritance when you are sure you can do.
Before writing extends, ask yourself, is this really an is-a relationship? And then ask, could I make this more flexible with composition? So now you know, inheritance means is a relationship, and composition means has a relationship. If this explanation made the difference clear, comment below, is a or has a. If you enjoyed the video, hit like. Subscribe for more beginner-friendly tutorials. See you next video. Happy coding!